downwards. So let's use this knowledge to graph these. So we have a vertex, which is the H and the K. Remember, that's the opposite of what it looks like. So this is actually a positive 3, and this is like regular. So this is negative 9. So the vertex is at 3, negative 9. So 3, negative 9. I'm going to use a different color now. And then you see that it says the parabola opens upward or downward. Well, we look here. That's a positive, so it opens upward. So if it opens upward, that means we have a minimum, a lowest point, All right. Now, compared to the parent function, let's use purple, to the parent function, which is y equals x squared, the parabola is going to be, okay, so this number right here is bigger than 1. Ignore the negative. Bigger than 1. That means it's narrower. If you need to, you can look at the other page, right? So our axis is symmetry. Remember, that's where it's like perfectly symmetrical about. If that's where it turns, this is the axis of symmetry, which is x equals 3. Not too bad. And then, ooh, it looks like we're going to have to do a little math here. So a solution. So you know how this is negative 3? Well, let's pick a point like maybe to the right. Let's pick like 5. Okay, so maybe we'll go 5. Let's choose 5 for x. So f of 5 equals 2 times 5 minus 3 squared minus 9. So 5 minus 3. So I can write that a little bit better. Equals 2 times 5 minus 3 squared minus 9. That'll give me 2. And then we square it, which is 4. And then 2 minus 4 is 8. And 8 minus 9 is negative 1. So f of 5 equals negative 1. So x is 5, y is negative 1. So a solution to the quadratic function is 5, negative 1. This point will make the equation true. Since the parabola is symmetrical, if we have 5, negative 1, 5, negative 1, then I go 2 across, then there's another point at 1, negative 1. Another solution is 1, negative 1. And then we can always sketch it in, if I can somehow do that. I can probably draw that a little bit better. Something like that, right? It's not perfect, but let me try it one more time. All right. So that's better, right? Okay. Let's do it again. So the quadratic function, remember that this is the opposite. So this is negative 5. This is the same, so it's positive 6. So negative 5, positive 6. Negative 5, positive 6. Cool. And because this is negative, it's going to open like that, downward. So it's going to have a maximum, a highest point. This means the highest point. Minimum would be like a lowest but it doesn't have a lowest because it keeps going down. So compared to the parent quadratic, so we look here, will it be wider or narrower? Well, remember, we ignore this negative. 1/4 is less than 1, so it's going to be wider, less than 1. I put A. Absolute value of A was less than 1. If it's narrower, the absolute value of A is greater than 1. Okay, so let's go ahead and put our vertex in. Oh, we already did. And let's talk about our axis of symmetry. That means it will be symmetrical about this line, right? It'll be like a reflection over this line, which is x equals -5. So x equals -5. Now we need to find another point. So if I were you, when I look at these, I would get a multiple of this maybe, but I don't know. We'll just put in any number, right? I guess we use blue. So f of 5 a lot more room. F of 5 equals -1/4 times 5 plus 5. Oh, I have to choose one that makes sense. So I'm going to choose -7. See, I have to choose something to the left of that or to the right of that. I'm going to choose -7. So I'm going to do that first. So I get -1/4 times -2 plus 6. And then I'm going to do my exponents. -2 times -2 is +4 plus 6. Now I can multiply -1/4 times +4 is -1. And -1 plus 6 is in fact +5. Oh, that was nifty. So f of 5 is actually 5. Remember, that's my x, and this is my, well, this is my x, and this is my y. So we have 5, 5. Another solution is 5. Oh, that wasn't 5. What did I do? Oh, I put a -7. I don't know why I have this 5 here. Oh, because I changed it earlier, right? So I need to do this actually. This was, I substituted -7. I changed that, remember? So f of -7 is +5. So that means we have -7, +5. So -7, +5. Sorry if I confused you. Remember, I originally was going to put in 5, but it made no sense. So then I was like, well, it needs to be around this point. So I chose -7, but I never like changed that to -7. That -7 goes, remember, I put it in right here. So that means this point, -7, 5, will make the equation true. So, and since the parabola is symmetrical, another solution is, well, if that's that means we're right here. Another solution is -3, 5. Cool, and then I will go ahead and draw that in. So this one kind of goes like that. Like that. Something like that, right? Cool. And that's it. Thank you.